trying out before. It had like the gray static and it was really loud. I don't know if you heard it downstairs. So, good evening everyone. My name is Tom Coles. I'm a software developer and trainer at InfoSupport. InfoSupport is normally a consultancy company, but recently we got into the habit of making sauce. So we have awesome sauce. And what I really think is awesome is seeing new speakers step up and say something in the stage, because it's really frightening, because as a speaker we really don't really have a reason to talk to you. So what we still do it. So to present, go with something little. The small surprise. I have a small surprise for him. I have the official awesome sauce. So so all right. I have some more, and I have awesome sauce stickers. So if you want some after the talk, please come to me. So I said I was a trainer, and as a trainer, one of my main concerns is actually this. This is a toolbox, but it's not any toolbox, it's actually your toolbox. You get a toolbox, you get a toolbox, everyone gets a toolbox. It's basically my Oprah Winfrey talk. Everyone gets a toolbox. But the toolbox is not a real toolbox, I'm sorry. It actually represents all the things we know, all the things we've learned, all the frameworks we know. It's basically the baggage we carry along. It's the experience that we got from doing previous projects. And it's really important to keep expanding this, because the more tools that we have, the more ways that we can look at a problem and try to fix the problem in different ways. And it's actually quite creepy how fast our industry goes. Because if we look, things that were pretty hype today can be just a normal standard tomorrow. So I don't know how much experience you have, but let's just go back through the years and see which frameworks weren't available yet. And I'll start very recent. So recently they announced Quarkus. I don't know if anyone has experience with Quarkus, but it's been really hyped up now. Well, let's go back in time and see how creepy it gets. Graal VM was released in 2018. Spring Web Flux 2017. Kotlin 2016. So that's pretty recent. I saw a few Kotlin developers here. So before that time there was no Kotlin. Kubernetes 2015. If you look at how common Kubernetes is now at conferences and such, it feels very weird that it's only 4 years ago. Spring Boot. I don't know, I see some Java developers laughing, but it's hard to remember a time before Spring Boot. Well, let's be honest, it's hard to remember a time where we didn't just make an application that just worked. Docker 2013. So that's only 5-6 years ago. So we constantly need to learn new things, because when these things appeared, they were just hypes. But eventually, they became very standard in our industry. But there's a problem, and the problem is called Halflife. And a half-life is the time required for a quantity to reduce to half of its initial value. Now, what does this have to do with the things we know? Well, there's also a half-life on our knowledge. That's actually been described in a lot of papers. So, what do you think is the half-life of relevant knowledge in IT? How much time does it take before half of the things that you know become irrelevant? And I will give some pointers. In the 1920s, this half-life was 30 years. Yeah. In 1960, it was between 12 and 15 years. Yeah. If I would ask you today, 2019, what is the half-life of your knowledge? So how long does it take if you learn something now, that it's no longer, half of it is no longer relevant?
I think
6 years.
2 years. 3 to 4 years.
3 to 4
5.
years? 5?
2
Well, it's estimated to be 2 to 5 years. So pretty wide range. Everyone's a winner. Awesome. No, but that's not a really long time. So this means that we constantly need to keep evolving, need to keep learning. So for tonight, I thought, you know what, I see a lot of people struggling with keeping up with learning, keeping up with knowledge. So tonight, I'm really going to highlight a few things that I think, as a trainer, are important for you as a learner to know when you want to keep adding things to your toolbox and keeping your toolbox up to date. So we'll be going through a few things, but I will be jumping to the first part. What is it actually that we should be learning? Because not so long ago, the only way that we could learn something was by reading a book or going to a class. But how do you learn today? Well, where do you get your knowledge from? Internet. Okay.
Stack Overflow.
Stack Overflow. Yeah. Only for crisis situations. Co-workers. Co-workers.
Online training.
Online training.
Online training.
Yeah. If you look at the amount of videos that are available on Plural site, it's about 7,000 videos only for IT. And my personal experience, and I see this in a lot of people that I talk to being a trainer and giving trainings, is that it's often quite overwhelming. You have no idea where to start. There's so much knowledge to be gained, but what are the things that I should be learning? Where do I invest my time? And you learn a lot of new stuff. If you want to pick something that you want to learn, what most people often do, which is a really good thing, is look on Twitter. If you follow a few key people, they will usually tell you suddenly your wall will be full of Quarkus. So I'm following a few people, and recently they released Quarkus, and suddenly my entire Twitter wall was full with Quarkus, and it's being hyped now as the ultimate framework. So even by looking at your Twitter feed, if you follow the right people, you can see what frameworks that are worth your time. Conferences. You don't even have to go to conferences, just look at the topics that they teach you at conferences, and those are usually the things that will become more popular or are already popular and that you can invest time. Or meetups like this one. And Co mentioned the technology radars. Yeah. The technology radar is an awesome website to see which things are trending. But there's one more awesome thing than looking at a technology radar, that's actually creating your own technology radar. So at InfoSupport we had a nice session where we decided, you know what, we're going to get all our developers together and we're just going to talk about what tools and frameworks do we use and how are we going to construct our technology radar. Just for the discussion alone, it's worth it, because Martin and I had a giant discussion on SOAP, and SOAP was still relevant.
I recall that one.
Yeah. So even SOAP can still be relevant. So you can use these resources as a guide on what topic should I choose. But there's something very important that you should always remember, and that's the zone of proximal development, which is an idea that you cannot learn everything. Now, I know that I'm in the Netherlands and darts is very popular here, but don't go for the bullseye in this case, because the bullseye are the things that you already know. Around it are actually things that you're capable of learning. Because the way that we learn is we connect new knowledge to previous knowledge that we already own. So for example, if you want to learn TypeScript, but you already know JavaScript, then there's a good chance that you'll be able to do it. But outside the zone, there's actually a zone of things that you just can't learn. And this sounds like a very simple idea, but it's sometimes hard to recognize when you're trying to learn something that's outside the zone. At some day, I spent the entire day trying to learn a bit of machine learning, because I thought, hey, machine learning sounds easy enough. I know it sounds arrogant, but sometimes you can't really see it. For example, when you want to learn Quarkus, so the new hipster framework. I'm sorry, I call it hipster. We recorded, so that's not good. But Quarkus is really the new framework. What are the things that you need to know to learn Quarkus? Because when you look at it from the outside, it's just a new framework that's probably here because I know Java. But what turns out, Quarkus is actually a combination of multiple libraries, including, you need to know JAX-RS, you need to know a bit of Vertex, and you need to know GPA. So from an outside, it looks like Quarkus is in here if you're a Java developer, but I think for junior Java developers, it could be that it's outside of their reach. So whenever you're trying to learn something new, try to investigate where it actually fits in this realm, and if you're already capable of learning it, because often we're developers, we just want to start hacking about, but make sure that you're capable of learning it in the first place. And then a very important lesson. Technical implementations die faster than the concepts they're based on. I don't know if anyone saw my talk here last year. No one, maybe some people. Well, some people remember, yeah. I was able to come back, so it's probably not been that bad. But last year I gave a session about Hystrix, which is a resiliency library. Does anyone know what happened to Hystrix in the past year?
Got killed.
It got killed. But that wasn't what my session was about. My session, yeah, I used Hystrix, but my session was actually about circuit breakers and bulkheading. And those two concepts, so the concepts of my talk from the last year are still valid, and concepts just last longer than the actual implementation itself. And sometimes we just hack about and we learn a framework real quickly, but we forget to really grasp the concept that they're trying to implement. So try to focus on those concepts when you try to learn something, because it will last you a lot longer. But yeah, all this talk, I can learn all day, but if I never apply what I learn, then I will always be using my tools in the wrong way. Because you can learn a lot of theory, but as long as you don't use it, your tools are essentially useless in your toolbox. So we need to learn through tinkering and apply what we learn. But what actually is tinkering? This is something that I forgot in the first version of my talk. I was talking about learning through tinkering, but I didn't make a definition of tinkering. So here we go with the definition. Tinkering is experimenting with an idea or a framework in an integrated environment to try to fully understand the details and their capacities. So experiment sounds like it's just some hobby, oh yeah, I tried the framework, it's fine now. And that's for a big part what it is, getting a first feeling, a first hands-on. But next to that, it's in an integrated environment. So I don't just want to make one Spring Boot endpoint, for example. I want to make it integrated in a bigger whole. So I can see where actually this little new puzzle piece that I'm making, where it fits in the bigger picture. And then I talk to my colleagues and they say, yeah, Tom, that's nice and all. I have this thing that I want to learn, but I actually have no inspiration. How do I start creating something? How do I start tinkering? And I actually have a few examples of how I try to approach this. Whenever I have a new framework that I want to learn, I have a few ways that I inspire myself to start doing kind of little experiments, to start tinkering. And I'm going to give you a few examples. And the first concept is really limiting yourself. And limiting yourself sounds like you won't learn that much, because you're limiting yourself. But actually by limiting yourself, you're learning a lot more. Because our brain is a really annoying piece of machinery. It's great at one thing. Whenever you see a problem, the brain will go back in its history, hopefully not its browser history, but its history, and it will try to find a similar problem that it solved, and it will apply the same solution on that problem. So if you're not careful, your brain will actually trigger you into making the same solution each time. And that's dangerous if you want to learn. So by consciously limiting yourself, you're actually forcing your brain to be more creative. And that's when I thought, you know what, I want to learn a bit more about object-oriented programming. I'm going to build a small game. But, and this is the limiting factor, I'm going to do it only in Java. I'm not going to use any framework besides Android or JavaFX, because I need to have something to draw. But besides that, I'm not going to use any framework. So I need to solve two major problems now. Problem one, I need to build a game framework, because there's loops and there's drawing and so on. And number two, I need to make sure that there's physics, because this is like a Flappy Bird clone. The physics are gravity and jumping, but it's still physics that you need to have. How do you go about doing that? Well, you start Googling. And what I found was actually on Kilobolt, a guy, James Cho, who explains piece by piece how to create a gaming framework. And he does it in such an elegant way, because he creates interfaces for everything first. And later on, he explains how you can implement these interfaces. So I've done this piece here in code. This is the JavaFX one. You can actually see to the left here, these are all the interfaces that he defined. Oh, a bit bigger. So it's really interfaces, there's no implementation here. And then for each platform where you want to build the game on, you can start implementing methods that are relevant. So for drawing, I haven't implemented everything because I'm lazy. So it's a really good example of how you can actually work with interfaces, decouple all your code, and actually the entire framework only talks through these interfaces. There is no platform-specific code in this entire thing.
But this is tinkering.
What?
So the tinkering to me has like element of hands-on. You work from the details and you may abstract later on. Tinkering is like really exploring.
It is for a big part exploring, that's true. But I found by wanting to build something, I found this solution already, so I just took it. It's not necessarily tinkering and discovering yourself, that's a part of it. It could be that that's a part of it. But in this case, I just put myself before a problem and I had to find a way to solve the problem, whatever way I found. But there's more, I have a few other examples that are closer to what you're implying now. And then I need to actually, after having these graphics, I need to solve a second problem. I need to have physics. And there's a really amazing book, Being the Nature of Code. Has anyone heard about the nature of code? No? No. Nature of Code is actually made by Daniel Schiffman, who has The Coding Train, which is an amazing YouTube channel. And he actually shows you how to implement physics in a really, really simple way. So I have a short example for this. So it's basically all based on vectors. So you have one class, which is an x and y, like this, a 2D vector, and then you have multiple vectors, because something exists of 3 vectors. A location, which is where I am, a velocity, which is how fast I'm going, and then there's an extra vector being the acceleration. How fast am I actually moving or slow am I moving? So if you combine those things together, you actually get a really nice programming model. And I have an example here. Is anyone a fan of Portal, the video game? So I see a few people nodding. So this is a companion cube, and as you can see, it has gravity that impacts it. And the way this looks is actually pretty easy, which are these lines. So the do logic method is where I update my thing. So I have something that when you press the space button, it goes back to the top, so it just resets everything. And when it collides with the floor, I set the velocity to 0, so it will instantly stop because it's colliding with the floor. And then to make the gravity impact, I actually have one method called apply force. And when you think about it, everything is just a force that impacts an object. So at this moment, you're all being applied gravity on you. But there's also a force that's keeping you up, so that's the floor actually. Now, this is a really simple, hey, it falls. So what does it take to add a force in this example? Well, you have a vector. Now let's say we add a force called wind. And wind is not a vertical force, but it is a horizontal force. Oh, that's not going to be wind. Then all I need to do in this update logic is just say here, cc dot, apply force. Cc stands for companion cube, so the little cube that's falling. It's a companion, it's cute. And then we say we apply wind. So let's see how that looks now. Oh.
And it's gone.
But if you see, it's actually a really easy programming model, but because what do I need to do programming-wise to change the force? Yeah. Just change this vector. So I'm going to put it a bit lower. So it's a bit better. Yeah. So by trying to limit myself, I actually learned how to build these physics things myself, which is quite amazing because by tinkering and kind of exploring, you learn things that you didn't necessarily expect. You can go in with a learning goal, hey, I want to learn more about object-oriented programming and how these things work, but you can discover a lot of extra things as well. So limiting yourself is the first one. Next up, automate whatever. Did any one of you go to JFall this year, which is a conference? There was a guy who automated his guitar. Yeah. That could just automatically play a song with Raspberry Pis and motors. Mine wasn't that cool, but I'm going to tell you a short story. So I had the enormous privilege of being a teacher at a university for half a year. And one of the things that you have to do as a teacher, at least when the attendance is required, you need to make sure that you have an attendance list. You need to write down, hey, Martin, are you here? And then they put up their hand. Thanks for cooperating, Martin. So much enthusiasm. But I was really, that's better, that's beer up. But I was really, not happy with this because it took me some time each lesson. So I thought I'm gonna automate this. And you have a free API that's called the Cognitive Services Face API, which is just a simple REST API that will allow you to recognize faces. Which is cool. But I have a problem, because the API, so I'm inventing problems for myself, that's all this talk is about, inventing problems. So the API only takes images. A camera is a stream of images. So I can do two things. Either I send every frame I take to the API, which will cost me thousands of euros each month because it's not a free API, or I put something in between. And that's when I went into OpenCV. And OpenCV is actually a pretty simple framework. Only problem is that it's a native framework. I have a simple example here. So it's pretty simple. You select the camera because it will allow you to have multiple cameras. If you plug in a USB and you have the frontal one, it works. It actually comes pre-packaged with a face detector algorithm. So that's what's happening on this line. I instantiate the face detector and the algorithm is in XML. Who would have thought? Who knew? Who knew? And then we basically loop forever. So while through loop forever, we read a camera frame. We do the detection, which looks a bit nasty because it's doing it by reference and not a real clean method where you have an input and an output, but it works. And then I draw rectangles on each of the faces detected. And then, if I find a face, so if the amount of detected faces, which is just an array, is more than 0, means it found a face, you send it to the cognitive services to detect the face. So that way I have a camera stream and I put this in between. So what does that look like? Now I have to. Hi, see? Can you see the green lines? Yep. So that works. So I was very, very excited. I had automated my attendance list. I was very happy about all of this. But, and this is not necessarily a technical lesson.
GDPR.
Exactly.
Yeah, GDPR wasn't really in effect yet because it was a couple of years ago. Which helps when you try to automate stuff like this. So at some point, one of my students came to me and said, hey, I tried it, it's not working for me. Every day I come in, every day I'm here, and never, it recognizes me. And I thought, awesome, this is like an awesome learning experience. I'm going to take this student, we're going to look at the code, we're going to find what's wrong. And I set him next to me, and suddenly I realized what was wrong.
He didn't have a face.
Worse.
Too dark.
I had made a racist attendance list.
Oh.
And it even recognizes me. It's
In the belly.
Oh, indeed.
So this was really awful. And actually, these are the things that you learn while you're doing these silly kind of experiments. Don't trust an algorithm you found online. Just don't. But you can automate cool stuff. And actually, automation is great because it has two benefits. One, you learn about the thing that you're automating, you learn how it works. Because if you don't know how it works, you're not able to automate it. Because it's really a nice step progress. But if it does work, the automation, then you have a nice tool to put in your toolbox. So it's something extra you have. Now, another thing you can do is replicate something that exists. And a lot of developers are like, ooh, but that's not cool because it already exists. Why would I build something that exists? Sounds kind of boring. But actually, when you think about it, most of the websites and tools that we use are actually quite top-notch. They're really difficult to make. Try making your own Netflix. Yeah, that will be crazy. And the cool thing is if you try to replicate something, you immediately end up at all the latest new cool stuff. You will probably use Docker, you will probably use streaming, HTTP2, all the cool stuff will be there. Now, replication can be cool. And if you really are stuck in your head with like, no, I want to try something new that's never been made before, that's no longer tinkering, that's having a serious business plan, and please go do something with it. So, but I wanted to think bigger. Does anyone know what this is? There's a little guy here.
Fusion.
It's CERN. It's the Large Hadron Collider. Oh. Now, I'm not saying I wanted to replicate this, partially because I'm no physicist. The other part is I'm from Antwerp and we're really bad at building big rings. especially around our city. But what they do at CERN is basically they accelerate two particles really, really fast, and then they smash them together. And they do that in the hope of trying to figure out what are these particles made of, like smaller pieces. And we have a term for that in engineering as well. It's called reverse engineering, trying to take something apart to learn more from it. And for me, I had this thing in the summer of 2016. Does anyone know what happened in the summer of 2016? It's actually perfect that we didn't say this. But Pokemon Go was released.
Oh, yeah. Yeah.
And I thought, I really want to make something better. I want to be the very best. So for the people who know Pokemon, that's... And I thought, I want to make something that's better than Pokemon Go, because Pokemon Go at the first minutes was a really bad game. It was crashing all the time. And I found a website, Pokemon Go Dev, which actually did the reverse engineering for me, but I could use their lessons to build my own stuff. And this is one of the first pictures I found. And it's creepy, so it's weird because it's not even REST, it's an RPC endpoint, so it's one endpoint for the entire game. And then this, because I was expecting JSON, but it wasn't. No JSON? What? So by trying to reverse engineer this, actually my world was kind of collapsing because I was so used to JSON. No, actually it's protocol buffers, and by the way, Martin, this is where I have this from. And protocol buffers is a nice serialization framework. It's even faster than JavaScript when you serialize, deserialize in Java to Java communication, and it actually looks pretty nice. My bar is gone. So this is an example. So this is what a protocol buffer looks like. So it almost looks like, I'm going to put it a bit bigger because it's pretty small. So it's basically a schema message. So this is what a message looks like, and it defines the structure of what you're putting across the wire. And it's actually pretty simple. It has a type, a name, and an index, and actually the name doesn't matter that much because everything is index-based. So whenever you get a protocol buffer, it will look at two things. It will look at the type and the index, and actually the name it doesn't care about. It will just put it on that position. Now, but this is useless in essence because this isn't code. I have to make Java out of this. And luckily there's just a compiler that can do this for you. There's a Maven plugin. And when you've done this, this distance walked actually looks like this. So I have a nice builder pattern up here. So this is a generated protocol buffer class. And don't look inside because no.
Make it stop.
Because no.
Make it stop.
No. But when you use it, it actually looks pretty good. It has a simple builder pattern to build the message that you want to build. And then you can just say 2-byte array. And then you have a byte array, a serialized object that you can put across the wire. So just zeros and ones, easy. And then you can deserialize it again by just going class.parseFrom. And to make sure that this works, I wrote a test for it, because you should always write tests if you want to verify something. What was that about IntelliJ and caches? So it works. So protocol buffers are actually amazingly fast, way faster than JSON when you want to communicate between two things. And they're pretty easy to use in this case. But there's something else. Because I was looking through the protocol buffers, I need to put on my glasses because the face detection actually didn't work without glasses. With glasses. There's something else, and that's in the code they found something called S2. Does anyone know S2 geometry? No? So normally when you have a position where you are, it's latitude, longitude. So this office, I looked it up online, these are the coordinates for this office. But it's really inconvenient to index in a database, because you have 2 points. How are you going to index something when you have the entire world you want to map? Because that's what Pokemon did, they mapped the entire world. There's no way to index this, because if you change this a bit or this a bit, it's totally different points. So what they thought is, you know what, do you know those globe lamps that you used to have maybe as a kid? So the world globe in your bedroom, if you take a see-through box and you put it over it, so you project the globe onto the box around it, then you actually get this when you draw it over. So then you have the world in 6 squares. How many bits do you need to map 6? 3 bits. 3 bits. Okay. And now each of those boxes you divide into 4. And then when you have such a box, you divide it into 4 again, you divide it into 4 again. So you get progressively smaller boxes to work with. But you can always draw a line through it without ending, and without ending at the same box 2 times. And if you do this enough times, you have very small boxes, and you can index the entire world with one number that is incrementing constantly. And this is what it looked like. So we had 3 bits, those are the face values. So from the big box you had, you stretch it out, you have the face value, which are 3 bits. But then you divide them into 4 each time, and to map 4, you need 2 bits. So that's actually the cell a bit lower. And then you have another box, which you divide into 4, which are the next 2 bits. And so you keep going and going and going, and then you have a terminator bit to make sure this is the last box. Pop question.
No. Oh.
If a 0 cell has 85 million square kilometers, how many levels of cells will you have before you end up at 1 square centimeter?
Yeah.
No
60?
60? No? Another guess?
25.
Closer? Closer?
30.
30, exactly. You need 30 levels, and then you're actually at a square centimeter using this technology. So let's reiterate. We have 30 levels times 2 bits, because each level was 2 bits. We have 3 bits for a level 0 face, so that's the 6 initial faces. And you have a terminator bit. You can map every square centimeter on Earth in 64 bits. How convenient that it's 64, by the way. So that's this. Every centimeter on Earth can be matched in this. So this is highly inconvenient to read, so they usually put it in hexadecimal, which is short.
Which is still.
Yeah, but it's quite incredible. So these are the things that you can learn by taking things apart, and it's really an amazing, eye-opening experience, because this stupid game, it's really a stupid game when you think about it, it's just tossing a ball. But this game actually showed me these things, and I use protocol buffers at my project now, which is awesome. But it also showed me, like, hey, you want to be able to scale? You should probably learn about Kubernetes and Docker. So by taking this game apart, I actually inspired myself to learn about microservices and circuit breaking and more. It can be much more than just a simple thing that you're building. One of the last parts is to challenge. Challenge each other, challenge yourself, and get the best out of it. So for example, recently was the Google Hashcode Challenge. I don't know who participated in Google Hashcode. So coding challenges and challenging yourself and others are actually a good way to learn things, to learn more, especially if you do it with multiple people. And for us, we actually did it, and I need to watch my time a bit. So is that clock actually accurate? Do I have 10 minutes left? Or?
It is
We
actually
still have the time, more than 15 minutes, 16 actually.
Whoa. Good. I get it. Yeah, there's no clock. I could see it. So. But challenging, and challenges are cool. But the way we did it was War of the Tanks. So our company, Info Support, actually got us 11 of Panzer tanks. And this is supposed to be a video, but it's not starting, so. Hello? Yeah.
Yeah.
So, come on, go for it. And pew.
Yeah.
Oof. So you have a bit of recoil. So our company gave us, divided us into 11 teams. They gave us a tank. They gave us 250 euros to build, to buy Raspberry Pi, sensors, whatever. And they gave us time to work on this. Now that's really cool. I should maybe explain a bit more. So the challenge was to make these autonomous, to make, because this little blue thing actually detects infrared and the barrel shoots infrared, so you could actually battle other tanks with it. So the idea was, 1, have a race, finish a course the fastest. 2, hit targets. 3, one-on-one battles, and the 4th and the last battle would have been all against, well, free for all, everyone against everyone, with 11 tanks.
You never got to that stage.
Keen observation, because this is what our company looked like after 2 rounds. So it sounds weird, right? It sounds like an awesome challenge, because we got the tanks, we got the money, we got the time, but still after 2 rounds, this is what it looked like. Which is weird. But so let's look at why do we sometimes quit a project, especially a tinkering project, before it's even finished. Why do we quit these things? And the first one is, I don't like doing it. And if you don't like doing something and you quit, that's fine. If you, for example, build a chatbot and it turns out you don't like building chatbots, that's fine, then just quit. That's a valuable career lesson if you have such an experience. You don't like building chatbots. But then at least have the guts when your boss tells you, hey, I have a chatbot project for you, and you say, oh no. No, it has to have a career impact in this way. You can't just say, yeah, fine. Another one is too much new stuff, and this is a trap a lot of developers fall into. They think, I'm going to make a project, and I'm going to learn a new front-end language, and I'm going to integrate it with a new back-end language, and I'm going to use reactive programming instead of imperative programming. And they think, yeah, if I combine all of this, I'm going to learn a lot. But learning too much actually slows you down. Because you're constantly looking, oh yeah, how do I do a variable declaration in Kotlin? Okay, back to my code. Oh, how do I do this in Kotlin? And I'm saying Kotlin because it looks like Java, but it's slightly different, so it messes with your brain as a Java developer in the beginning. I see people laughing, so...
Your ID can change it, huh? Convert it.
Yeah, IntelliJ. Nice plug, nice plug. So learning too much stuff. Because learning is always connecting new information to existing knowledge. But if you're trying to learn too much, there is no knowledge you connect the new knowledge to, so you are not actually learning that much. Misplaced competition. This is not really a personal issue, a reason why you quit, but this is a reason you can quit when you are actually being challenged. Because the whole idea of those War of the Tanks challenges was to get us to collaborate more. Yes, it's a challenge, we're going to battle each other, but in essence, we're all part of the same company, and we're supposed to share knowledge, learn from each other. But because it was a competition, and it was marketed as a competition, what happened? I've never seen so much private repos in my life. Every team was hiding their code. Oh, how are you doing it? No, this is how we're solving it. You're not allowed to see it. So because the competition was misplaced, actually it had a lot of bad side effects. We didn't share enough knowledge with each other. And also, you had teams where people were very competitive and people who weren't very competitive. And the competitive people basically said, no, I'll build this. So we had mixed teams with very senior people, very junior people, and the juniors usually dropped out because the senior people were taking all their work. They didn't want to invest time that they got from the company to say, oh yeah, I'll help this junior learn about how to automate this thing. No, they said, I'll do it. And the juniors dropped out. So that's a real shame. And the last one, this is actually the reason why my team quit. Seeing passion encouraged. And you can see that I'm doing the fingers, passion. Because one of the rules that wasn't very clear in the beginning, but a rule that they added on the first day of the first competition was, when you win, you get 11 points. Second place gets a little bit less points and so on. But there's actually another way to get points. If you build the coolest, most awesome sauce solution, then you get bonus points. You get 7 bonus points for making an awesome solution. What does this teach you? They're not encouraging passion. They're encouraging unpaid overtime. Because the teams who eventually were scoring the highest were the teams that invested 30 extra hours at home. So we got some time from the company, which was nice, but they are also giving bonus points, so you couldn't win if you weren't investing extra time. And this is actually a horrible predicament to state to your people. Which actually brings me to my last question. When should we be tinkering? And I see, as I said, I'm a trainer myself, so I often get the question, can you give this training to us? How much will it cost? And the question I get asked most recently is, can you do it from 1 to 9 in the evening? If you think about it, basically and then I ask, why do you want it in the evening? Learning is hard work. It's a lot of effort to learn something new in a day. Yeah, then the first half of the day they're still billable. I can still, they're still useful that day. But what I get as a trainer is I get people who already worked half a day, are pretty tired, and at 5 in the evening they're done. The last 4 hours I can do nothing with them. Even if they're good people, it's just over for that day. And I see this really as a growing problem in our community, that more and more emphasis is put on you have to learn in private time or you will not make it. So, should your employer give you time to tinker? What do you think? Should they?
Of course.
Yes.
Of course. Maybe I put it a bit too blunt for you, so the only thing you dare answer now is of course.
You have to weave it in your daily job, I think.
Yeah, that's a good one. I'll come back to that statement in a bit. So yes, absolutely, they should give you time to tinker. Because this is actually Bloom's taxonomy, it's one of the things they teach you when you're becoming a teacher. And they basically say that without remembering, you cannot understand. Without understanding, you cannot apply something. And what our employees want from us are the top 3 things. Our employees want us to create. Our employees want us to evaluate certain solutions. Is this framework good enough to use in this use case? And our employees want us to analyze things. So if this is what they want, then they should allow us to exercise this. Yeah, cool. Because tinkering is already a win-win story. Because as employees, you're motivated. You actually are more self-assured. Because when I have to build a new thing and I can use protocol buffers, I'm pretty sure that protocol buffers will be a good fit. If you've tinkered with something like Scala before and someone asks you, will you do a Scala project? I can assure you, you will be way more certain about yourself than when you've never done anything in Scala before. And on the other side, for your employer, it's actually less turnover. People will be more happy. You will be happy to stay with you. You can grow the company from within. See people evolve and continue on, and better productivity. Big part is to share what you learn. Because it's already win-win, but you can make it more win-win for your employer if you learn something at a conference and you then share what you've learned with the rest of your colleagues. It's not only a win for your colleagues, it's also a win for you. Because talking at a meetup or even a conference or even a small meeting at your office, it will force you to think deeper about what you have learned. You will do more research. If you look at the numbers Sko has, those are not just Googled online. He put effort into making a presentation and showing it. So by teaching and sharing what you learn, you actually learn more yourself as well. But in this question, who is responsible to update and maintain your knowledge?
You.
Yeah, you are.
Yes.
So whenever you get time from your employer, make sure you put the best use to it. If you're allowed to go to a conference for a week, don't spend the entire week in the conference halls. Take time off to go outside and go apply what you've learned. Because you will remember nothing. Well, Nothing is a bit crude. They say that you lose like 90% of what you learn, you will forget again. Unless if you apply what you've learned. Because in the end, it's all about the stool box. These are your toolboxes. You're supposed to take care of it. You're supposed to grow it. You're supposed to take care. So I showed you a couple of things tonight. What you can learn, where you should look at, how you can tinker. So what I want you to do is choose one thing that you've learned, something from your backlog, something you've been wanting to learn, and just take some time and go tinker with it. Go do it. Go do something with it. Because if hours and hours of watching Bob Ross paint won't make you a master painter, then hours and hours of Utrecht JUG won't make you a better programmer. Thank you. That's my talk. About the interreading, absolutely. So I don't think it's necessary that your employer gives you dedicated time. There are moments, for example, when you're doing a sprint, you should slot time to actually investigate things. I'm also right now a lead developer in my team. I have 2 junior people. I have no issue with it to have an hour, maybe even 2 hours, that I explain them a framework that we're using, because they're not used to it. Because it pays back really, really quickly. If they understand, they will feel more comfortable. They will just, when I do a code review, I don't have to like say, oh, that's shit, that shit, that shit, that shit. No, it's better code. Even pair programming, you can teach your colleagues a lot about, this is how I do it. Oh, that's, you do it different? Okay, that's fine. Maybe we can combine our knowledge and make a better software. So absolutely you should interread it. What I'm mainly trying to say here is, it's your responsibility. Make sure you make the most of it. Any more questions? Otherwise.
Actually, if I was, or let me start somehow else. If I was at your place, I would say my question will be completely off topic. However, I want to ask it regarding the in-house or the internal competition. Did you, at any point at least, raise it to the management that it was, how you said it, empowering unpaid overtime, right?
Yeah.
Did you communicate it?
No, I tell you why I didn't. Because this is a really subtle thing. They don't just advertise and say, hey, I want you to do unpaid overtime. It took me actually a long time of just being angry about I lost and I have no really idea why. So I went to a pub and got some beers after the competition, but no, I didn't raise it. And that's probably my biggest mistake in the past years.
Don't get me wrong, it's not about talking a specific organization. I mean, nowadays we see more and more big organizations failing in the way of trying to empower people or to steer the mindset of the people, the direction they would like to do so. And I believe we should always raise this.
Yeah, absolutely.
Not literally, in general, I mean it.
Yeah, absolutely. I can't say anything but absolutely, because I think you're absolutely right.
Yeah.
But I do believe, and that's actually what you're saying between the lines as well, that the responsibility lies with us.
Yeah,
don't wait for your employer to give you time. If you need time to study something because you're going to be put on a new framework, ask time. And if you don't get the time, then honestly, you should be able to convince them. And if you're not able to convince them, they're just, yeah, but why would I invest in you? They're not saying it, but what they're implying is, why should I invest in my people when I can just hire someone else? As soon as you get that feeling, run. No, sorry, just run. Yeah, go.
What are your thoughts about the Masters of Java, the competition there? They also going to have a competition in Java, and program in Java. What are your thoughts about it? Yeah.
I've never participated in the Masters of Java, so I cannot comment.
No, because competition is something.
The competition it can be good to motivate people.
Yeah.
But you need to be really careful when you put competition in a place where you actually want collaboration.
Yeah.
Because Competition has been seen even in schools. You see, oh yeah, you get a star if you do well, and you get. Well, actually, what you want to promote is that people work together and learn together, not like, oh, I have a better score than you, haha, you loser. Because what you actually create is not one winner. You create, in our case, since we were with 11 people, we have one winner and 10 losers. That's what you create. That's the feeling you create. So challenging is good. Being challenged is good. But try to make it a collaborative effort if what you want out of this thing is collaboration. Cool. Anyone else?
Any more questions?
No? Okay. Thank you
Thanks
for
a
having me.
lot.